In example number 1, it says that triangle JDA is dilated using the scale factor k equals 3. Graph and tell the coordinates of the image. So if it says that it's being dilated, it's telling you that that figure is either going to be made bigger or smaller, and it's going to depend on what the scale factor is. So if you looked at the notes, remember a scale factor is going to be the number that you multiply by that actually does the dilation for you, okay? So in this problem it says that the scale factor is 3. And so that means you're going to take, essentially, by the end of this, the lengths of all of the sides are going to be multiplied by 3. And so if you kind of think about it, that means that it's going to make the figure bigger, okay? So what do we do to actually dilate it? Well, you can't really take the lengths of the sides because we don't really know the lengths of the sides. I mean, we could find them, but there is another way to dilate it. So what you're going to do is you're going to take each of the coordinates individually, and you are going to dilate each one separately, and then once you graph it, you would have dilated the figure, okay? So to begin with, we're going to start by taking each one of these coordinates and figuring out where they originally are. So J, where is J originally? Well, remember to tell the coordinate, you start at the origin. So we have to go right one and up one. So that would mean that J is at 1, 1. D is at -2, 1. So D is at -2, 1. And then A is at, let's see, -1, -3. So A is originally at -1, -3. Okay, so to dilate it, all you have to do is take each one of these coordinates and then you multiply it by the scale factor. Okay, so what we're really doing is taking the x value times the scale factor and then taking the y value times the scale factor. Okay, and so if you wrote it as a rule, because we've been talking about rules, what are you doing to the x and y values? Well, xy, you're going to take the x value and you're going to multiply it by 3. So that's what that part of the rule would look like. And then you're going to take the y value and multiply it by 3. So if they asked you to write the rule, you now know the rule. Okay, so that's all we have to do. So to figure out where J prime lands, or the image, you just take the x value times 3. So 1 times 3 is 3. And then you take the y value times 3. So y, or the 1 times 3 is 3. So J prime would end up at 3, 3. Okay? D prime, you do the same thing. You take the x value times 3. So -2 times 3 would be -6. And then you take the y value times 3. So 1 times 3, you get 3. Okay? Then A, well, same story. You take x value times 3, -1 times 3 is -3. And then you take the y value times 3. -3 times 3 is -9. Okay, so this is actually the coordinates of the image. Okay, so that's part of your answers. So box it in, and then the only thing left to do is just to graph your coordinates. So J prime ended up at 3, 3. So 1, 2, 3, 1, 2, 3. That's where J prime landed. And then D prime landed at -6, 3. So 1, 2, 3, 4, 5, 6. And then 3, 1, 2, 3. That's where D prime landed. And then A prime ended up at -3, -9. So 1, 2, 3, 5, 6, 7, 8, 9. So there is my A prime. Okay, and then from there, all you have to do is connect your dots. And then if you've done it correctly, it should kind of look like it is 3 times the size of when it started. Okay, so the lengths of the sides should be about 3 times as long. And you could, if you actually had a ruler, you can measure them and double check. So We're going to dot this one so that we can definitely tell a difference as to which one is our pre-image and which one was our image. So if you do not have a ruler, remember you can always use the edge of a sheet of paper to kind of help you draw some nice straight lines. It's just using your resources, so whatever you've got, as long as it has like a straight edge on one side, it should work. So there we go. And so notice it's definitely got bigger, and it's actually 3 times the size of the original figure. Okay, so that's how you dilate a figure. All right, so let's practice another one. So number 2, it says you've got quadrilateral, which just means it has 4 sides, and then it gives you the coordinates of each one, and it says it's dilated using the rule. So they actually give you the rule here, and then it says identify the scale factor and then graph the image. Okay, so well, what would be the scale factor? And remember, they usually use a K for that. So let's look at the rule to figure out what the scale factor would be. So remember, the rule tells you what's happening to the x and y values. So if we look, they're taking the x and they're multiplying it by 1/2, and then they're taking the y value and they're multiplying it by 1/2. So think about what the scale factor is. It's the number that you're multiplying by to dilate it. So if we're taking our x's and our y's and we're multiplying them both by 1/2, then the scale factor would be 1/2, because we have to take each one by 1/2. And so the only other thing that it says we have to do here is graph the image. So let's do it. So that means I have to take each one of these coordinates and I have to multiply the x and the y values by 1/2. Okay, and so just so we can compare them in a minute, I am going to go ahead and graph the original one. So let's graph it. So J originally was at -8, 6. So 1, 2, 3. Ooh, my graph's messing with me. 1, 2, 3, 4, 5, 6, 7, 8, and then 6, 5, 6. So that's where J is. F is at 3, 3. So 1, 2, 3, 1, 2, 3. That one was a little easier. K is at 1, -10. So 1, 10. So that's where K is. And then P is at -8, -8. So that's 8, and then -8. 1, 2, 5, 6, 7, 8. All right. So now let's label them. I always like to sometimes wait to label them so that I know I don't interfere with my figure. And then let's graph it. So when I connect them, it's going to be a really big quadrilateral. And so if you look at the scale factor is 1/2. So that means that you're multiplying the lengths of these sides essentially by 1/2. So it's actually going to make it reduce the size of it. So it's actually going to end up being smaller than when it originally started. And so, you know, that's kind of a good way to know if you've done something correctly is, you know, if it's supposed to get smaller, make sure that it actually got smaller. And so if it ends up getting bigger, then you've definitely done something wrong. So maybe you should go back and check, right? And so that's something you can look for. All right, so we're going to take each one of those coordinates and we're going to multiply the x and the y by 1/2. So let's see where our coordinates land. So J prime, if I take -8 times 1/2, I get -4. If I take 6 times 1/2, because it says we have to multiply our y's by 1/2, that would give me 3. You're essentially just dividing it by 2 when you multiply by 1/2. F prime, if I take 3 times 1/2, or if I take 3 divided by 2, it actually ends up being a fraction, so you could write it as 3/2, or because we're graphing it, I'm actually going to write it as a decimal, so that would be 1.5. And then if I take the y value times 1/2, I would get the same thing, 1.5. For K, where did it land? Well, if I take 1 times 1/2, or if I divide it by 2, I end up getting 0.5, or 1/2. -10 times 1/2 gives me -5. And then for P, same story. I take the x and the y and I multiply by 1/2. So -8 times 1/2 gives me -4. And then -8 times 1/2 gives me -4. Okay, so whenever I graph this, it should actually be half the size of when it started because I've chopped everything by 1/2, or in half, in other words. So when I graph it, it should look that way. So let's see. So J prime was at negative 4, 3. 1, 2, 3, 4. 1, 2, 3. So they ended up right there. F prime was at 1.5, 1.5. So F prime, I go 1, and then I go half. And then to go up, I go 1 and then halfway. So it ends up kind of like in the middle of this box right here. So that's where F prime land. See if I can squeeze my little F in there. And then K prime is at 0.5, so it's like right there. And then negative 5. So 1, 2, 3, 4, 5. So notice I kind of stay in the halfway point right there. So that's where K prime landed. And then P prime is at negative 4, negative 4. So 1, 2, 3, 4, 1, 2, 3, 4. And then there we go. So when I connect these, you will notice that it has definitely reduced in size because it's smaller than what it was. And again, you could actually, if you had a ruler, you can measure the lengths of the sides, and the lengths of the sides should actually be half of what they were. All right. So the last problem that you could see is something like this one. They might actually give you a graph, and they might ask you, what is the rule? Okay, so essentially they're asking you, what did they do to dilate it? Well, there's a couple ways that you can figure this out. So if you had a ruler, you could figure out what was happening to the sides. But if not, like notice let's say we don't have a ruler. What you could actually do to figure out the rule is you could pick a coordinate in the figure and then pick the one that matches up with it, or the corresponding coordinate in the image, and see what happens. So I'm going to just pick a coordinate here, and it could be any one of them because it should be the same thing that happened to all of them. And so I'm going to just pick A, and I'm going to look at where it originally was. So let's see where A was originally. It's at 1, 2, 3, 4. So negative 4, 2 is where it originally was, negative 4, 2. And then I'm going to look, where did it land after it was dilated? And notice, this is the original figure because it doesn't have the primes with it. This is called the pre-image. And then this one is the figure after the transformation. So that's called your image. And so I'm going to see, where did A prime land? Well, let's see. So 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. So it landed at negative 8, 4. And then I'm going to look specifically at my x's, and I'm going to ask myself what happened to my x value. And then I'm going to look at my y value, and I'm going to ask what happened there. And remember, with dilations, whenever it's getting bigger or smaller, that means you're multiplying the x's and the y's by something. So you're looking at what number did you multiply by. Okay, so let's see. What do I multiply negative 4 by that would give me negative 8? And if you think about it, you'll realize that if I take negative 4 times 2, negative 4 times 2, that gives me negative 8. So that means I am actually taking my x values and I'm multiplying them by 2. So that's that part of the rule. And now you look at the y value. What am I doing to the y value in this dilation? So what do I do to 2? That would give me 4. And if you think about it, you'll realize that if you take 2 times 2, that's what gives you 4. So you're actually taking 2 times your y values. And so there you go. So the rule for this dilation was you were multiplying by 2. So if they asked you for the scale factor, you would say that the scale factor was 2, because that's what you were multiplying by. So there you go. That's some examples with dilations.